Hi, Assalamualaikum. My name is Nur Nasar binti Masaid. My CAD metric number is AE190054. So right now we would like to present our project, which is PID controller design for control the speed of electromechanical system. So we are from group 2, and this is our group members, Nurul Ain Fatihah, Haris Saifuddin, Ramira and Nuna Suha. So next, I would like to present the introduction of our project. So a proportional integral derivative controller, which is PID controller, is a closed loop system. PID controller is a control loop feedback mechanism that has been used in more industrial control systems. So a PID controller calculates an error value as the difference between a measured process variable and a desired set point. The controller attempt to minimize the error by adjusting the power through use of a manipulated variable. Electromechanical system, or we can call EMS, are physical structure characterized by electromagnetic field interaction and inertial bodies. The interaction can be described using quantitative equation, which is Frost law, that describe the interaction of Maxwell theory and mechanics. A mathematical description oriented by classical analytical mechanics and complete by some basic concept and method of a graph theory to characterize topological properties of electrical network plays a critical role in discrete EMS modeling and simulation. So in this paper, we will show the full calculation manually and simulation using MATLAB software about the PID controller that control the speed for electromechanical system. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nur Amira binti Saimi, which CAD metric number is AE190047. Now I will be presenting the literature review part of this project. So in this chapter, we will focus on the conducting a literature review for each project elements. So based on the findings during the project completion, each element will be discussed in details. So firstly, an electromechanical system such as a DC motor gives a greater speed, control performance, and a huge speed of control range. A DC motor essentially consists of three components: a stator, rotor, and a commutator. A wide range of speed control is essential for robotic and actuation applications. The basic property of a DC motor is that speed of DC motor can be changed by adjusted the terminal voltage. DC motor is widely used as it is inexpensive cost and it is simplicity and is used extensively in research industry and laboratory activities. Next is PID characteristic. So there are three approaches to dealing with the error. So first is to use the proportional term to handle the present. Second is using the integral term to recover from the past. And the third one is use the derivative term to forecast the future. To control the DC motor speed in this paper, we will utilize a basic open loop system and a closed loop system with a PID system. So there's a three characteristic of PID, which is Kp, Ki, and Kb. So what is the function of Kp? Kp will be used to reducing a rising time and a steady state error, but the percentage of the overshoot will increasing. Next, for the Ki, it will reducing the rise time but get rid of the system steady state error. And the last one is Kd. It will enhance the performance by increasing the system stability and the transient specification. And this is part of the research study that we have found in order to do a literature review in this project.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Haris Saifuddin bin Haduddin, AE19005. So I will present about the progress equation and the result. So from the this data parameter, we get the transfer function this value. So what the main thing I want to do is the manual turning of the PID gain. So manual PID gain, I will skip all the conclusion and go to the result For the gain PID tag for P is gain P for is 59.326, and for the PI is gain P is 53.394, and gain I is 76.2763, and PID is for the gain P is 71.1912, and in I we get the 169.5029, and gain D is 7.4751. So I will do simulation by doing the MATLAB. So we are gonna do this plot diagram, or we are gonna open the MATLAB. So we're gonna run the for the first step is 500 RPM. So this is our response for the 500 RPM. And then for the 1500, so we get this response for the graph. And then for the next step is we're gonna create the system for the PI, for the P controller. So for the P controller, use the gain. We use this gain for the P gain, for the P controller. Controller here for the, so this 1500 RPM. This is our response, and then what we need to see is 900 RPM. So this is our response for the 900 RPM. So after that we are gonna do the for the PI controller. We're gonna run for the 900 RPM. So we get here for the response for the 900 RPM, and then we need to see the 1500 RPM. These are the response for 1500 RPM. So after that we're gonna do the PID control manual. Run it. So this is a response for the 900 RPM for PID controller. So that you see the 1500. It's so similar from that. So it's response for 1500 RPM. So after that, after we design the PE and PI and PID controller using the without controller for the open loop. So you're gonna do the for the auto tuning. So auto tuning is we open back We are gonna tune it. So today we update the block. So we update it. We run it. So we get this graph. So this is our stabilized the signal in here. And then we're gonna compare between the manual and the automatic. So gonna take scope. So bus. So we now run it. So this is our comparison. Yes. And then this for the yellow is for the manual and the green is for the automatic. So we can see that the manual is stable faster more than the automatic in here. So then what we need to do is parallel comparison to the LED control response, improve multimeter tuning, and then the error peak time. So we're gonna then unestimated to compare the PID manual and the automatic is we're gonna get the PID controller. So this PID we're gonna change it with the manual calculation. So again 01 and then this again this 100. So we're gonna apply it and then tune it. So this dot line is for the manual calculation and the line is for the automatic controller for PID. So also show parameter, so you can see it the rest time and setting time in here, and operation also peak, gain margin and pace, and also the closed loop stability. So both of them is stable because PID system. So that's all from me. Thank you.
Assalamualaikum, my name is Nurul Al-Fatihah and my matric number is AE190073. To conclude our project, we found that the PID control system function in controlling the speed is widely used in electromechanical system industry. One of the major examples is a DC motor. With success to stimulate the given block diagram and calculate the PID gain manual from given value. From the calculated value, we success in creating our own block diagram, stimulate the manual tuning PID, which is the closed loop, system without control, which is the open loop, and automatic tuning PID control. We also can differentiate the PID control gain from manual and automatic tuning, where we found that the automatic tuning is much more stable than the manual tuning. Lastly, we can plot the comparison between the input versus manual tuning and input versus automatic tuning. So, that is all from our group. Thank you for watching.